This conference will now be recorded.
Hello, everybody. Jordan Girth from the National Weather Service Office of Observations here. Thank you for joining us. Hope you're staying well. And as we head into summer here, we have an exciting presentation today on incorporating satellite products into severe weather operations with an example on May 7th, 2020. Before we get started, I just have a few reminders for everybody. One, that this session is being recorded, so please keep that in mind. We will have a Q&A about 15 minutes after the presentation, or I should say the Q&A will be after the 15-minute presentation. I would encourage everybody to post their questions in the chat room if you can. That'll help us prioritize and make sure we capture them and get them addressed for you. For those of you in the field offices, we're always looking for future presenters. So if you have a topic related to satellite imagery or satellite products and how you're applying it in the forecast process, we'd love to have you in the Satellite Book Club. There will be a feedback survey that's sent around. So if you have feedback on how we can improve this seminar series, please let us know. And if you see something that you might not know how to access in AWIPS, or perhaps you don't even have it in your office AWIPS, feel free to reach out to the Tower S team. They're able to help you with anything related to data access and AWIPS configurations. And then finally, when it comes to using the products, we have a great training team out there that can help create training materials that may be unavailable. So there's a wide amount of expertise and materials that are out there to support Weather Service use of satellite data. I'd just like to say thanks to our Tower S team, David Blutis, Lee Byerly, for their role in setting up the Satellite Book Club seminar series. We have had a very strong run of it here. And also thanks to the Office of the Chief Learning Officer, Ross Van Til and Brian Mata, been instrumental in helping to set up the technical arrangements, and then our program support from the GOZAR and JPSS program. That includes Matt Siebold, Dan Lindsay, Mitch Goldberg, Bill Schoberg out there. A lot of great support we've had all the way around to bring this seminar series to you. So without further ado, I'd like to introduce Caitlin. Caitlin Rutt has been a forecaster with the Weather Service for 2 years in Amarillo, Texas. I enjoyed working with Caitlin when she was the satellite focal point or the satellite liaison for the Warning Decision Training Division, and now is a satellite focal point for her office and is engaged in leveraging satellite products in their everyday operations. So thanks, Caitlin, for putting this presentation together, and I'm looking forward to it.
All right, thank you for the introduction. Like you said, I'm Caitlin Rutt. I'm from the National Weather Service in Amarillo, Texas. And today I'm going to talk about incorporating satellite products into severe weather operations, specifically on May 7th of 2020. Okay, so looking at a little of like the mesoanalysis role, just to give you an idea of what was going on that day. This is the 19Z 500 millibar analysis. And you can see that there's an upper level low digging into the central plains. Along with that, there were a few perturbations that were coming off the mountains in Colorado and New Mexico that would cause a little bit of some short waves advected over the Panhandle region later that afternoon. Along with that, there was about a 40 to 50 knot westerlies over the Texas and Oklahoma Panhandle. Looking at the 19Z 850 millibar analysis, you can see a closed low set up over northeast New Mexico and south central Colorado. Along with that, there was a tongue of low-level moisture present in the eastern Texas and Oklahoma panhandles, along with the western Oklahoma, and that will kind of be a primary role later on in the afternoon. And then there were also some southwest winds at 850 millibars that was pulling some warmer air into southeast Texas panhandle, and that will again help us reach our convective heating and break that cap from that morning. So looking at the 19Z surface analysis, you can see the surface low again correlated with the 850 millibar low. on the New Mexico and Texas border. Surface temps are in the upper 70s to upper 80s, but once again, this is at 19Z, so we did warm about 10 degrees more across the board, which we did end up reaching our convective heating temp that we needed. And then the surface dry line, I've drawn that in right here. That was a key factor that day. That was our main boundary we were working with later that afternoon, and that was present from a line from about north central Kansas to southwest Texas. So we did launch a 19Z sounding at Amarillo, and you can see that we were reaching convective heating enough, and we were slowly eroding that morning capping inversion. You can still see that inversion just below 700 millibars. So we did warm slightly more to eventually break that. Amarillo did have about 50 dew points present at the surface. So it was pretty clear that the dry line was right over us, and it was kind of shifting a little bit to our east. We did have southwest winds at the surface, so we were on that drier side, but we were getting some of that moisture as the dry line was kind of bouncing back and forth over our area. We were looking at most unstable CAPE values of around 1,500 to 2,000 joules per kilogram. And then the mid-level lapse rates were around 8 degrees Celsius per kilometer. There was enough buoyancy out there to create some large hail if a storm did occur. As far as the effective layer shear, we were sort of limited in directional shear, but we definitely had the speed shear. You can see that with the hodograph. And the hodograph also hinted at splitting supercells right away. You can see that just from the hodograph, and that will play a big role when I go through the analysis later. So we're going to start looking at the upper level water vapor analysis first, and this is the GOES East 6.2 channel, and it does show that upper level low present on water vapor analysis. So you can see that kind of digging down into the central plains. You can also see some of that moisture along the Rockies that was caused from those perturbations, kind of little short waves coming across, and that's what caused some of our high cirrus earlier in the day. And then the last thing is you can see that surface dry line actually present in this upper level water vapor. And it's very hard to see, but you can see it mainly in Texas. And I've drawn in a line to kind of show where it started. But as you go in time, you can actually see that dry line does recede west a bit and retreat west through the day. And another thing you can see is that the storms are firing right along that dry line, which happened to be right along the Cap Rock as well. So the big question lied in where will storms initiate. So this is a rocker loop that visible imagery, and it rocks forward and back. And you can see that storms are actually beginning to initiate in southwest Texas along the dry line. So we knew that the environment was unstable enough to support some sort of storms. And the best instability, again, was east of the dry line, mainly in that southeast Texas panhandle. It was looking the best for our area. You can see that high cirrus is present across the southern Texas panhandle. Again, that was from that moisture coming off the mountains. But another thing to note is we did get a nice Q field forming, a cumulus field along the eastern Texas panhandle and western Oklahoma. And that actually started to fill in more west in that southeast Texas panhandle region. So looking at the NOAA 20 availability, we were actually lucky enough to have JPSS-1 have its orbit track go right over southwest Texas at 20Z. And you can see that in the left image. And on the right, that's our new cap sounding availability. And you see that most of Texas actually had soundings available. All of those green dots indicated that. The nice thing with the new cap soundings is then you can then plot some of the information. So this is the horizontal interpolated gridded new caps of total precipitable water. And what's really neat about the total precipitable water is that it did give us an idea of where that dry line was setting up. You can see that gradient of higher TPW versus lower TPW. Another thing that you can see is that storm at 20Z, that storm was already initiated down in southern Texas. And you can see that there's higher total precipitable water in correlation with that storm. And so we knew that there was enough moisture in the air there. Well, another thing that you can plot with the new cap soundings is the gridded new cap maximum CAPE values. And so this is kind of a nice way of doing a little mesoanalysis, and you can plot that without actually having to look at the sounding, you can get an idea where's the higher CAPE values. And so in this case, you can see that there was a maximum bubble of CAPE and just up here in the Southeast Texas Panhandle. And you can see it's about southwest of Childress, Texas, if you're aware of where that location is. And it was kind of like, well, we have a green sounding. Let's check out what's going on in that area. So I've circled the dot that we chose to look at, and you can see that the sounding is on the right. There are plenty of CAPE that day. So you know that we don't launch soundings just about anywhere. So we had a sounding from Amarillo, but we didn't really have a sounding in the area where the best instability was. And now you can look at RAP soundings and other model soundings, but this was just something supplementary that you can look at along with those. And so one thing to note is that mostly that capping inversion had broke. But the thing was, there was a bit of an inversion anywhere from the 600 to 700 millibar layer. And if you were able to get a storm going, there was enough buoyancy that you could push and break through that easily. It was just a matter of getting a storm to fire in that area. Another thing to note was the steep lapse rates. You could, with a sounding like this, you could definitely get large hail possible. And I'll just give a spoiler alert for that because I am not going to talk about the hail-producing thunderstorm that it moved on to be, but it did produce a very large hail as it continued into, I believe, Norman's area at that time. And I will show you where there's a blog about that later. But did convective initiation occur? Well, y'all know that I just spoiled that it did occur. So we did have that cumulus field, once again, present along that Texas and Oklahoma border. And with time, again, we had more cumulus clouds begin to fill in to the west, and that was in the Southeast Texas Panhandle, while we had storms initiate in the Southwest Texas along the dry line. And so about an hour or so later, after those storms in the Southwest Texas had started to initiate, we started to get our initiation. And the one thing that we used was the GOES East Day Cloud Phase Distinction RGB. And what's really neat about this product is you can get an idea of when storms are starting to glaciate and actually become mature convection, so deep convection. So in this case, you can see at the beginning, convective initiation was imminent. You had your blue colors, which is your cyan water clouds, and we were seeing that form in those Q clouds. But then you start to get a little bit of a green tint, and you'll see that there are a few orphan anvils as well. So we were seeing these clouds glaciate and turn green. And then we were starting to see some of these orphan anvils, and we were seeing that the anvils were kind of detaching and decaying from the updraft. And we weren't sure, okay, well, where were these storms going to form? We had some high cirrus around that was blocking some of the view, but then we noticed right around Clarendon, all of a sudden, we started to get a little bit more of an orange and yellow color. And that hinted that that storm was able to get enough of an updraft that it was becoming deep convection and it was maturing. And that is how we ended up getting our convective initiation. And we saw that all through satellite. So here's our radar loop. So it was a little bit later, we started to watch the storm develop. And we started to use satellite to look at the splitting storm possibility. And so the left image is actually your Vis-IR sandwich combo. And then your right is just your NexRad base reflectivity. And that's every 5-minute intervals. And so what was really, really neat about this is that the satellite, you can watch that there's that main updraft. But with that main updraft, you could start to see an above anvil cirrus plume, which meant that there was intense cloud top cooling. That updraft was strengthening. But then right there, you see a new updraft development. And how did we know that was a new updraft development? Well, we started to see cloud top cooling again, but we also started to see some texture in the cloud. And we thought, is this another updraft forming alongside just to the northeast? Hinting that the photographs were saying splitting cells were definitely possible. We took this into consideration. Now we started to see that first hint of a split on satellite around 2216Z. And at that point, radar started really indicating that split just a few minutes after. So it was only a few minute leeway with the satellite, but it was enough that 1 minute imagery could give you a heads up and we were able to put a severe thunderstorm warning out for the far corner of our CWA, knowing that this storm was going to split and clip our corner and potentially create some hail. And so that was the one thing that satellite really helped us with when it came to the splitting supercells. And so later on, we had a second round. And so we ended up having a cold front push down from that upper level low. And we had that dry line set up over us. And then we had that cold front pushing south. So we were lucky enough to have the cold front intersect with the dry line. Now, I was on the radar desk that day, and I was watching all these storms come down into south central Kansas, and I see them fire along the cold front. By the time it got to our area, it almost seemed like the Oklahoma Panhandle didn't want to, initiate any storms. It kind of created a gap. And I noticed that in the satellite imagery, so on the left, you see the east IR imagery. You can see that the cloud tops actually, you can see some of the high spheres come in, but then you see the cloud tops cool fairly rapidly. And I was able to pick up on some of that rapid cooling before radar. Now you can go up and see cores with radar, so you can get a heads up with radar analysis, but sometimes you don't realize if it is rapidly intensifying. And something with satellite that was useful was you could see these updraft overshooting tops, and you could see that they were bubbling and they were intensifying very rapidly compared to what the storms in the north were doing. And you were able to see, hey, these are going to grow pretty fast. Let's get some warnings drawn up and ready, because this could intensify pretty rapidly. Another thing that happened, as you can see on the radar analysis, is that most of the cells were isolated, but they were in close proximity. So they didn't really become super completely linear until it got to Oklahoma. We were having kind of individual cells. And so satellite was really useful in seeing these individual updrafts. And you could monitor the updraft, the cloud top cooling on it to see, is this a new updraft that's forming? Is it intensifying? And then you could also see if it was decaying, or if there was, if you were having an updraft redevelop and it was recycling itself. And so the IR imagery was very useful in monitoring what was going on with these updrafts. And we did end up using lightning analysis as well. Unfortunately, I don't have that plotted here, but lightning analysis paired with the satellite imagery actually helps you to look for lightning jumps, which could also indicate an updraft was intensifying slightly before the radar would even show that. So there's one other product that's really kind of useful to look at, and that's the GOES-derived CAPE. So just like the new CAP, instead of it being the polar satellite, it comes from your GOES satellite. And what it is it's the derived CAPE values that it's seeing. And since it's seeing where obviously there are no clouds, one thing that's really useful is taking these CAPE values, plotting them, and then overlaying a visible satellite over top, so that you're not just seeing black spots. And so in this case, this is your visible, it's your IR, or this is your IR because it's at night. So in the day, you could use visible. This is IR, but it's grayed out. And you can see that your derived CAPE values are plotted underneath. Now, this is for the entire event. And this is something that is an additional mesoanalysis that is very useful. You can see that there's a ton of increased CAPE values, and it was present across the whole eastern panhandles. And you see that first storm initiate right in that pocket of high CAPE values off that dry line. And then you see it move on. No storms had fired in that northern Texas panhandle, the northeast Texas panhandle, eastern Oklahoma panhandle. And you see that pocket of higher CAPE remained. And so as that cold front moved south and intersected with that dry line, it hit that high pocket of instability. And that's where our storms really kind of took off when that cold front came down. So that was just another tool that you can watch and see where is the environment the best. And this is something that's telling you as frequently as 5 minutes or so as the satellite updates, whereas your SBC mesoanalysis may be hourly updates. So this is just something that gets you thinking on the more quicker pace. And so that is all I have for today as far as that storm analysis on May 7th. My contact information is here, but I do want to acknowledge Bill Line, Scott Lindstrom, and Scott Bachmeyer. all three of them help. I helped Bill put together a satellite liaison blog. That is the first link there. That is actually a blog that pretty much describes this presentation to a T. And then the SIM satellite blog that both Scotts put together has more information on that NewCap sounding information. And then just for anyone out in the field that is interested in knowing when the polar satellites are orbiting, I found this link very useful. This is a third link below. But this is a link to show you when the predicted orbit tracks are going to be for JPSS, so that you can kind of get an idea of when you might have that NOAA 20 NewCap sounding availability. And with that, I will take any questions.
Thank you, Caitlin. That was terrific. At this time, yes, we will open it up to questions for Caitlin. And with the size of the audience, we do encourage you to please submit your questions in the chat room. If you would like to ask a question verbally, you can indicate that as well in there, and we could unmute you. So at this point, we will open up the questions. And I see one question here. The first question, Caitlin, from John, is Derived Cape available and goes west?
That's a good question, John. So this is something that I know I've had to work with my ITO on. I know that my Derived GOES products aren't necessarily in the satellite drop-down menu on our AWIPs, and sometimes you have to go into the product browser. And obviously, if anyone's interested, either you can ask your ITO or you can feel free to email me and I can look into that for you and get you that information. But I just know about the GOES East. At this point, I'm not sure if we personally are loading in the GOES West. I'm sure someone else that's more satellite capability will know, but I'm sure that it is available.
Yes, and we just got a confirmation from Brian Gockel. He did say that will be available via AWIPS data delivery. And we have another question here from Miranda. She asked, what exactly is the day cloud phase distinction RGB measuring, and how does the cloud scheme work?
Oh, yeah, sure. So it's just taking the RGBs. I can't remember exactly off the top of my head which three bands it's using. But basically, the day cloud phase distinction RGB, in my best description of it, is it's my favorite one to see convective initiation, because it's measuring where your water clouds are. Oh, there you go. Someone helped out. It's got the red visible, the clean IR, and the snow ice. And so what it's doing is it's seeing where your clouds are glaciating. So that's where the snow ice comes in handy. And then you've got your cloud top cooling, which is your clean IR, and then you've got your visible. And so what it does is it gives you an idea of when you're hitting that glaciating clouds into the mature convection stage. So I use it a lot when I'm looking at storms and when they're first starting to fire up. Where are we in that water cloud droplet phase? Where are we hitting that ice phase? And then where are we hitting that mature convection phase?
We have another question here from Tim. He says, as a forecaster, would you be interested in a combined sounding product, one that combines LEO and GEO info? There is research towards this.
I definitely would be interested. I know personally, I like to use the NewCaps. I'm still trying to figure out how to get it to fully work in my AWIP system. I've been working with my ITO, and I'm going to continue working because sometimes it's only passing over so often. So I think having something that combines would be really interesting to see how that works and how well the product would be used. I almost wish too, this JPSS predicted orbit tracks is something I didn't know existed. So it would be kind of cool if forecasters in the office had a neat way to know when they had access to that, when it was passing over their location at times, because it may not be something on the forefront of their mind when they're working their mesoanalysis role.
Question from Matt here. Do you also use lightning data, GLM, or terrestrial to help diagnose new or strengthening updrafts?
Yes, I do, Matt. Unfortunately, I will admit I am actually out of town for personal family reasons. So I didn't have access to my AWIPs. Otherwise, I would have plotted you guys some GLM, or I also use NLDN. And I love to use the tracking meteogram tool is one of the things that I personally love. I know that sometimes it can get bogged up and stuff, but I like to watch for those lightning jumps, the intensity of the lightning to see if the updraft is strengthening or weakening. It can tell you a lot, I think, about the storm. And I think that the GLM is really useful in doing that, telling you the flash extent density. I love to compare the GLM with the NLDN and see what they're both producing and compare those results.
Are there any other questions for Caitlin?
I'll just ask one question here. This is Jordan. Caitlin, you talked a lot about the qualitative use of the imagery. Are there any gaps in quantitative information that you would want that you don't currently have access to?
You know, I don't know if in the field there's anything quantitative that I can think of other than I know that the biggest thing that everyone runs into is the parallax issue, which I'm not sure if that falls under the quantitative route. But I know that that's something that's really useful, and that's why lightning is super helpful to overlay on satellite to get you the ground truth. But I have seen some research that does quantitative uses of the RGBs in pinpointing colors and seeing how much of the image has so much color. And I think maybe that would become useful, especially in the operations when you're looking at certain scenarios, not only with severe weather, but even fire weather, winter weather, anything like that. So it's definitely something I would tinker with it if it came out more, but it's not something I have been searching for, I guess.
Okay, last call for any last minute questions. And I'll just draw attention to the chat window there. It looks like Christopher White posted out a link to Orbit Tracks from a web page at Sport. So go ahead and check that out as well. All right, well, Caitlin, thank you so much for presenting today. Was very pleased to see that example of the satellite imagery and having you walk through your thought process and workflow with us. Matt Foster says, great presentation. I concur with that. Next week, we have William Straka, a researcher with the Cooperative Institute for Meteorological Satellite Studies, SIMS, and he's going to be presenting on the Veers flood and related products as they relate to the ice breakup in Alaska. So keep an eye out for the Tower S from the Tower S team for more information about that. And if there's nothing else, I'd like to thank everybody for taking the time out to be with us for this half hour. Stay well, and hope you'll join us again next week. Thanks, everybody.
Thank you.